current. The motion of positive charges in the opposite direction of the flow of electrons is called conventional current. Example: positive charges in motion for conventional current is the current of hole charges in p-type semiconductor. Also, a current of positive ions in liquids and gases moves in opposite direction of electrons. Electrical current: the current which is due to the motion of electrons only in the opposite direction of conventional current is called electron current. However, the direction of electron or electrons' current flow is from negative potential to positive potential. Ohm's law. The potential difference V is directly proportional to the current I through a conductor. There is no change in the physical state of the conductor. Ohm's law formula: 1 V equals IXR, 2 I equals VR, 3 R equals VI1. When voltage V increases, then current IA will also increase but resistance decrease. Exercise 1. How many amperes of current are flowing in the circuit solution? We know the formula that I equals VR, so 100 V for V and resistance 20.
Κεφαλαίο ωμέγα.
Into 100 V as follows. I equals VR 100 V/20 equals 5A. There are 5A of current in this circuit. Exercise 2. How much voltage is needed to produce 5A in the circuit solution? We know the formula that V equals IR, so 5A for I and resistance 100.
Κεφαλαίο ωμέγα.
As follows. V equals IR, 5A, 100.
Ωμέγα, ίσον.
500 V. There is 500 V required to produce 5A in this circuit. Exercise 3. How much resistance is needed to draw 3A of current from the battery solution? We know the formula that R equals VI, so 12 V for V and 3 ampere for I. As per formula, R equals VI 12 V/3A equals 4.
Μικρό ωμέγα.
There is 4.
Κεφαλαίο ωμέγα.
Required to draw 3A of current from battery. Conductor is a substance in which there is a constant random movement of free electrons atoms. Or conductors are materials that allow current to flow easily. Explanation: conductors have a large number of free electrons in their structure. Most metals are good conductors. Silver is the best conductor and copper ranking second. Copper is the most widely used conductor material, because it's less expensive than silver. Energy bands. Conductor is a substance whose valence band and conduction band overlap each other and there is no forbidden band or energy gap. Hence very small amount of energy need to transfer electron from valence band to conduction band where it becomes a current carrier. Conductivity. It is the ability of a conductor to conduct electricity is called conductivity. This ability is called conductance, which is the opposite of resistance. Its symbol is G. Unit is Siemens and old unit is mho. Formula: G equals 1/R. Siemens. Power. The rate of doing work is called power, or power is the rate at which energy is used. Its unit is watt. W. Watt. The power is 1 watt if the work is done in 1 second. To move 1 coulomb charge by applying 1 volt of potential difference, as P equals 6 but I equals Qt. So P equals VQT. 1 watt equals 1 volt x 1 coulomb/1 second. Or 1 watt is a power or rate of doing work when 1 joule of energy expended in 1 second. as power equals energy time. Or 1 watt is the power when work is done at the rate of 1 joule per second. 746 watt equals 1 horsepower. Energy. The ability of a body to do work is called energy joule. The joule is the work done when a force of 1 Newton acts through a distance of 1 meter in the direction of force. Formula. Energy equals power x time energy equals 60 equals with energy equals with or energy equals I2 T as V equals I or energy equals V2/RT as I equals VR.